Regents exam, Algebra 1, August 2016, problem number 29. Is the sum of 3 times the square root of 2 and 4 times the square root of 2 rational or irrational? Explain your answer. In this problem, we are asked to determine if the sum of these two numbers is rational or irrational. We also need to explain our reasoning. Recall that the real number system is broken up into two sets of numbers, rational and irrational. A rational number is a number that can be written as a ratio of two integers of the form a over b, where b does not equal 0. Numbers such as 0, 1/2, -8/3, and -5 are examples of rational numbers. Rational numbers can also be written as decimals. For example, the number 2 can be written as 2.0, or 2.00, or 2.000. We can essentially add as many decimal places as we want. Usually, we just write the rational number as just 2, without any additional decimals. The rational number 1/4 can be written in decimal form as 0.25 or 0.250. Or we can continue adding zeros similar to the number 2, but usually we just write it as 0.25. The number 2 and 1/4 are examples of rational numbers that have a decimal representation that terminates. We also have rational numbers whose decimal representation does not terminate. For example, the rational number 1/3 has a decimal representation of 0.333, and so on. This pattern continues indefinitely, forever and ever. Instead of writing all of those 3's, we can just draw ellipses in the end, or draw a bar on top of the digit that repeats as follows. At times, certain rational numbers have more than one digit that repeats in its decimal representation. For example, the rational number 25/99 has a decimal representation equal to 0.252525, and so on. So we would draw a bar on top of the first repeating digits, in this case 25, since these are the digits that repeat. In the same manner, the rational number 763/9999 has the following decimal representation: 0.076307630, and so on. This one has 4 digits repeating indefinitely. An irrational number, on the other hand, is a number that cannot be written as a ratio of two integers. For example, the number pi and the square roots of non-perfect squares, like the square root of 5, are examples of irrational numbers. When we write the decimal form of an irrational number, we obtain a non-terminating decimal, similar to a rational number. The only distinction is that the digits do not follow a predictable pattern, or have repeating digits like the rational numbers do. For example, the first 10 digits of pi can be written as follows. Likewise, the first 10 digits of the square root of 5 can be written as follows. Notice that there are no digits that repeat or terminate for either of these two irrational numbers. Returning to the problem at hand, we are asked to determine if the sum of 3 square root 2 and 4 square root 2 is a rational or irrational number. Since both expressions have a common radical expression, in this case, square root of 2, we can go ahead and simplify the sum by adding the coefficients of each radical expression. Doing that, we obtain 7 square root 2. Let's now use a calculator to rewrite this sum into its decimal representation. Notice that the decimal representation does not terminate, nor does it have any repeating digits. Therefore, this number is an irrational number. This means that this number cannot be written as a ratio of two integers. So this is our final answer.